Run your fingers across the desk in front of you. Go ahead, do it right now. Press down, feel the surface. It feels solid, it feels smooth. Now imagine running your bare hand over a piece of coarse, heavy grit sandpaper. You can almost feel it just by thinking about it. It feels rough, it bites back, it grabs at your skin. Your brain is telling you a very simple, very comforting story about what is happening in that moment. It tells you that your skin is making direct physical contact with the matter of the universe. It tells you that you are feeling the actual physical shape of the object beneath your hand. It says the desk is flat and the sandpaper is jagged and your hand is touching both. But you are fundamentally entirely wrong. You have never touched anything in your entire life. In fact, nothing has ever physically touched anything else. But this creates a terrifying paradox. If you never actually touch the atoms of the desk, if you are just permanently hovering on an invisible magnetic force field, how do you know what texture is? Why doesn't the entire world feel uniformly slippery? If you are just floating, why does a brick feel different from a silk sheet? Today, I am going to completely destroy your concept of touch. You are going to learn that roughness, smoothness, softness, and hardness do not actually exist in the physical world. You are simply feeling chaotic fluctuations in an invisible force field translated by your nervous system into a convenient biological lie. Your reality is about to shatter. Let me show you. Let us start by addressing the sheer arrogance of your biology. We are absolutely obsessed with the idea of contact. When you clap your hands together, you think meat is hitting meat. When you stub your toe on a door frame, you think wood is hitting bone. We trust our senses implicitly. We think that because we can see, hear, and feel the world, we understand what the world actually is. But your senses were not designed to be a microscope. They were not designed to reveal the quantum bedrock of physical reality. Your senses are nothing but a survival mechanism. Your brain evolved to help you throw rocks, pick berries, build fires, and run away from predators. It did not evolve to understand the electromagnetic interactions of subatomic particles. To keep you alive, your brain takes incredibly complex quantum data and simplifies it into a cartoon. It creates a hallucination. To understand why touch is a lie, we have to discard the cartoon. We have to zoom in, past the cells of your skin, past the DNA inside those cells, past the complex protein molecules. We have to look at the atoms themselves. You have been taught that atoms are like little billiard balls or tiny solar systems with a solid, heavy nucleus in the center and electrons orbiting around it like planets. That picture is a mathematical convenience, and mostly it is a complete lie. Atoms are not solid. An atom is almost entirely empty space. If you were to take a single atom from the skin of your palm and scale it up until it was the size of a massive professional football stadium, the nucleus, the protons and neutrons, the only part of the atom that contains any real mass, would be the size of a single grain of rice sitting right on the 50-yard line. Where are the electrons? They are not neat little planets. They are microscopic, ghostly blurs, teleporting around the very highest bleachers of the stadium, forming a fuzzy cloud of probability. And everything in between that grain of rice on the field and those electron clouds in the bleachers is a void, absolute nothingness. So when you press your hand against the desk, you are not taking two solid blocks of matter and pushing them together. You are taking two massive empty stadiums and pushing them toward one another. Why don't they just pass right through each other? Like two ghosts walking through the same hallway, why doesn't your hand simply sink through the wood? Why don't you fall through the floor and plummet toward the center of the earth? Because of the electrons in the bleachers. Electrons carry a negative electrical charge, and the universe has an absolute unbreakable foundational rule, like charges repel. Opposites attract, but likes violently repel. The electrons in the outer shell of the atoms in your hand absolutely despise the electrons in the outer shell of the atoms in the desk. As you push your hand down, those electron clouds get closer to each other and they scream at each other to back away. They repel each other with a force that is 10 to the 42nd power times stronger than gravity. That is a 1 with 42 zeros behind it. It is a force so monstrously powerful, so incomprehensibly violent, that human language completely fails to describe it. Compared to the electromagnetic force pushing your hand away from the desk, the gravity holding the planets in orbit is a joke. You have never touched a single thing in your entire life. Every single time you think you are touching something, your electron clouds are simply hovering a fraction of a nanometer away from the object's electron clouds, held apart by an invisible, impenetrable wall of pure electromagnetic fury. You are permanently hovering. You are a levitating entity. But this is exactly where your brain starts to rebel. This is where the paradox begins. If all you are doing is hovering, if you are essentially riding a microscopic magnetic hovercraft over the surface of your desk, why does the desk have a texture? Think about magnets. If you take two strong magnets and you push the two north poles together, you feel that squishy invisible resistance in the empty air. It feels smooth, it feels uniform. The magnetic force pushes back completely smoothly. You can slide them past each other without any friction. So if your hand is just being repelled by the desk magnetically, why doesn't the desk feel like a smooth, squishy magnet? Why does a piece of sandpaper rip your skin open and make you bleed if it never actually makes physical contact with you? To answer this, we have to stop looking at the world with human eyes. We have to stop thinking of surfaces as flat. You look at a piece of smooth mahogany wood and your eyes tell you it is perfectly flat. You look at a sheet of glass and you see a flat, pristine surface, but you are looking with hopelessly blind biological tools. Let us shrink you down until you are the size of a single electron. Now, look at that smooth piece of wood. It is no longer a flat surface. It is a terrifying, chaotic, jagged mountain range. Wood is made of complex biological polymers, cellulose, and lignin. These molecules are massive, chaotic, tangled chains of carbon, hydrogen, and oxygen atoms. They stack together in messy, irregular, unpredictable patterns. When you shrink down to the quantum level, you do not see a desk. You see deep, terrifying canyons of empty space. You see massive, jagged spikes of atoms jutting up into the sky like swords. It looks like the surface of a hostile alien planet. And you must remember, every single one of those jagged atomic spikes is surrounded by a cloud of negative electrons. This means the magnetic force field pushing back at your hand is not a flat, uniform sheet. It is not like the smooth magnetic field of a bar magnet. The repelling force field perfectly contours to the shape of those atomic mountains. The invisible field has deep valleys where the repulsive force is weak, and it has sharp, violent peaks where the repulsive force is intensely concentrated into a microscopic point. It is an uneven, treacherous landscape of invisible energy. Now, shrink down and look at the piece of glass. Glass is made of silicon dioxide. It is an amorphous solid, but at the microscopic level, its atoms are arranged in a much more uniform, tightly packed, flatter landscape. The mountains are very small. The valleys are very shallow. The magnetic force field hovering above the glass is highly uniform. It is essentially a flat rolling plane of repulsion. So what actually happens when you run your hand over these surfaces? You have to realize that your hand is also a jagged mountain range of atoms. Your skin is made of complex proteins, dead cells, oils, and sweat. When you move your hand across a desk, you are dragging one mountain range of invisible force fields across another mountain range of invisible force fields. When you drag your hand over the glass, your magnetic mountains glide relatively easily over the uniform magnetic plane of the glass. The repulsion is steady, the pushback is constant, there are no sudden collisions, but when you drag your hand across the wood, or worse, across the sandpaper, it is a microscopic, catastrophic car crash. Imagine you are driving a hovercraft. If you drive a hovercraft over a perfectly still, flat, glassy lake, the ride is incredibly smooth. The cushion of air pushes back constantly and you glide effortlessly. But what happens if you take that exact same hovercraft and you try to drive it over a jagged, rocky, dried-up riverbed full of boulders and deep canyons? You are still hovering. The rubber skirt of the hovercraft never actually touches the rocks. But as you pass over a deep canyon, the hovercraft dips violently downward. As you suddenly smash into an invisible cushion of air compressed against a jagged rock spike, the hovercraft violently lurches upward. You are bounced, you are jostled, you are violently shaken inside the cabin, you are thrown from side to side, you are experiencing massive chaotic turbulence. This is exactly what happens to the atoms in your hand. As you drag your hovering hand across the sandpaper, the invisible magnetic peaks of the sandpaper violently crash into the invisible magnetic peaks of your skin. The monumental 10 to the 42nd power repulsive force smashes the electron clouds together. Your atoms are violently pushed upward. Then they drop into a valley. Then they are violently smashed upward again. Your atoms are vibrating, shaking, and bouncing on a chaotic, invisible roller coaster of electromagnetic turbulence. You still haven't touched the sandpaper. There is still a gap of empty space between you and the object, but the invisible magnetic turbulence is violently shaking the atoms in your skin. And this is where the physics ends and the terrifying biological lie begins. How does a shaking atom turn into a feeling? How does an invisible magnetic collision become the sensation of roughness? To understand this, we have to look at the meat machine that is your body. Your skin is absolutely packed with highly specialized microscopic biological machines called mechanoreceptors. You have different types scattered throughout your tissues: Pacinian corpuscles, Meissner's corpuscles, Merkel discs. They sound like pieces of alien technology, and honestly, they operate exactly like it. These corpuscles are essentially tiny biological stress detectors. They are tiny capsules of fluid and membrane wrapped tightly around the ends of your nerve fibers. When the atoms in your skin are violently bounced up and down by the magnetic turbulence of the sandpaper, that physical bouncing travels through the tissue. It creates a microscopic shock wave of kinetic energy that ripples through your flesh. This shock wave hits the Pacinian corpuscle. The corpuscle literally gets squished. It gets physically deformed, bent, and stretched by the magnetic bouncing happening at the surface. What happens when you squish a mechanoreceptor? When the membrane of that cell is physically bent, it forces tiny microscopic trapdoors in the cell wall to pop open. These trapdoors are called ion channels. The moment the trapdoor pops open, positively charged sodium ions, which have been waiting outside the cell in the surrounding fluid, come rushing inside. This sudden violent rush of positive charge changes the electrical balance of the cell. It creates a tiny electrical spark, an action potential. The physical bouncing of the magnetic field has just been translated into a burst of biological electricity. This electrical spark shoots up the nerve fiber in your arm. It races up your spinal cord at speeds exceeding 250 miles per hour. It travels into the dark, silent, squishy meat of your brain, and it terminates in a highly specific region called the somatosensory cortex. Here is the most important part of this entire lecture. Stop whatever you are doing and listen to me very carefully. Your brain is completely blind. Your brain is locked inside a dark, thick bone vault called your skull. Your brain has never seen the outside world. Your brain has never seen light. Your brain has never heard a sound. And your brain has absolutely no idea what wood or glass or sandpaper actually is. All your brain ever receives, all it has ever known from the day you were born, are electrical clicks. Zip, zap, click, click, click. When you run your hand over the smooth glass, the magnetic hovercraft ride is smooth. The mechanoreceptors in your skin are squished gently and constantly. They send a steady, low-frequency hum of electrical clicks up your arm and into your brain. Click, 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 click. When you run your hand over the coarse sandpaper, the magnetic hovercraft ride is a violent, turbulent nightmare. The mechanoreceptors are rapidly, aggressively, and chaotically smashed. They rapidly fire a chaotic, high-frequency machine gun burst of electricity up your spinal cord. Click, 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 click. Your brain receives these electrical codes. It sits in the dark, receiving Morse code from the outside world, and it has to make sense of these codes instantly so you don't die. It has to tell you whether to keep holding the object or whether to drop it before it damages your tissue. So, it invents a lie. Your brain takes that chaotic, rapid-fire electrical signal and it projects a hallucination directly into your consciousness. It invents a sensation that does not exist in physics. It invents the feeling of roughness. Roughness is not a physical property of the universe. Roughness is not a thing out there in the world. Roughness is just the specific biological audiovisual translation your brain uses to represent high-frequency electromagnetic turbulence. Smoothness does not exist in nature. Smoothness is just the biological translation your brain uses to represent low-frequency electromagnetic stability. Think about color. You know that the color blue does not actually exist out in the universe, right? The sky isn't literally painted with a blue pigment. The universe only contains electromagnetic radiation, light vibrating at different wavelengths. Light vibrating at 450 nanometers enters your eye, hits the cones in your retina, sends an electrical signal to your visual cortex, and your brain paints it blue so you can understand it. Blue is a translation. Blue is a biological interface. Texture is exactly the same thing. Texture is the tactile version of color. When you pick up a rock and you say, "This rock feels sharp," you are speaking a biological fiction. What you should actually be saying, if you wanted to be perfectly physically accurate, is, "The atomic topography of this object is generating high-amplitude magnetic turbulence against my electron clouds. which my mechanoreceptors are translating into a rapid electrical firing rate, which my brain is projecting into my consciousness as the sensation of sharpness. You do not feel shapes. You feel rhythms. You feel rhythms of magnetic resistance, translated by a meat computer into a convenient, comforting story. But I know exactly what you're thinking right now. The engineers and the mechanics are already shaking their heads. Your intuition is fighting back, throwing up defenses. You're asking, wait, what about stickiness? What about friction? If I drag my hand across a rubber mat, it doesn't just bump up and down like a hovercraft. It grabs me. It pulls my hand back. It resists me. How do you explain drag and friction if we are just hovering in empty space? This is the ultimate trap of common sense. And to escape it, we have to look at the darkest, strangest secret of the empty space between objects. The electromagnetic force isn't just a shield that pushes things away. It is also a tractor beam that pulls things together. When your hovering hand gets agonizingly close to a rubber mat, you have to look at what the electron clouds are actually doing. They are not perfectly still spheres. They slosh, they vibrate, they ripple like water in a bathtub. For a billionth of a second, the electrons in a rubber molecule might randomly swash over to the left side of the atom. Because electrons are negative, this makes the left side of the molecule slightly negative and the right side slightly positive. We call this a temporary dipole. It is a flickering, momentary magnet. When the atoms of your skin get close to this sloshing, flickering molecule, it induces an absolute panic in your own atoms. The positive side of the rubber molecule reaches across the empty void and aggressively pulls on the negative electrons in your skin. This is called a van der Waals force. It is the physics of chemical adhesion. Instantly, millions of microscopic invisible magnetic tractor beams form in the empty vacuum between your skin and the rubber mat. The positive patches are desperately grabbing the negative patches across the gap. Your skin is still not touching the mat. The core electron clouds are still repelling each other, preventing the atoms from merging. But you are locked in a hostage situation. You are bound by millions of temporary, flickering, incredibly stubborn lines of electromagnetic attraction. So when you try to pull your hand forward across the rubber mat, what happens? The tractor beams refuse to let go. They hold on tight. You have to use the physical muscles in your arm, burning biological energy, to violently tear those magnetic bridges apart. As you rip your hand forward, breaking the invisible tractor beams one by one, the atoms in your skin snap back into place. They vibrate violently from the shock of the separation. They ring like plucked guitar strings. That violent snapping and vibration triggers your mechanoreceptors all over again. The shock waves travel through your tissue. The trap doors open. The electricity shoots up your arm to your brain, and your brain, sitting safely in its dark box, translates that specific tearing, snapping rhythm into a brand new sensation. It invents the feeling of friction. It invents the feeling of grip. You aren't touching the rubber. You are engaging in a microscopic quantum tug of war across an empty vacuum. You are breaking magnetic bonds, and your brain is lying to you about what it feels like to win that tug of war. When you truly grasp this, when it finally clicks in your mind, you stop seeing the world as a collection of solid blocks of matter bumping blindly into each other. You stop being a passive, confused observer of the physical world. You start seeing the underlying matrix of forces. You start seeing the universe as it actually is. Look around the room you are in right now. Look at the walls, the floor, the device you are listening to this on. You think you are an isolated, solid person sitting in a solid room, touching solid objects. You are not. You are a bag of mostly water, structured by complex carbon chains, operating a massive network of electrical wires. You are surrounded by an uncrossable void of empty space. You navigate this void by extending localized catastrophic fields of electromagnetic repulsion out from your body. You smash these fields against the fields of the universe around you. You bounce, you shake, you create quantum turbulence. And from the safety of a dark, silent bone vault, your mind listens to the electrical echoes of that turbulence and paints a beautiful, comforting masterpiece of textures, shapes, and solids. Texture is a lie. Touch is a hallucination. Solidity is an illusion. You are a hovering entity reading the ripples of a magnetic ocean, and that changes absolutely everything you think you know about reality. If this video successfully broke your common sense and shattered your perception of reality, hit the subscribe button. Your brain wants to go back to sleep. It wants to go back to the comfortable cartoon. Don't let it. We have a lot more comforting illusions to dismantle. I will see you in the next one.